So over here, so we're saying it's that please use summation notation to write the sum. So we are not really asking you to calculate it. I mean, we could, but what we want is that do you know how to write the summation notation? So what we want to make sure here is you know how to go between the list of numbers, add it together, and also the summation notation. And of course, if we need to ask you to find out the sum, you know the equation that you need to go for. So now what's the summation notation right here? Well, that's a summation notation. That's a sigma. And then we need to write down the nth term notation. And we say n starts from 1 and to a certain number that we need to find out. So now we have two major things to find out here. One is, hey, what's the nth term notation here? What's the nth term notation here? And also, what is the final term? What's the n value for this? Okay, what's the n value for this? So, for the first thing that we need to ponder is for the numbers here, we need to ask the question: are they arithmetic or geometric? In other words, are we adding numbers, like between the list of numbers, between the numbers, okay? Are we adding from 3 to 12 to 48, all the way to 12,288? Are we adding numbers or are we multiplying? Okay, it's very easy to see that we are multiplying, and we are multiplying by how many? We're multiplying by 4, right? So 3 times 4 is 12. 12 times 4 is 48. Very easy to spot out. And your first term is 3. Very easy to spot out. So we got a good few pieces of information already, but we just need to find out what the n is, because we need to know how to put the upper number of the sigma notation. So we'd say, yeah, what's the n value? Well, if we know that it is geometric, we can do something. We can do this. We know that this is the an, which we don't know what the n is, but we know the a1, or we know the r, and we know it's going to be n minus 1 for the exponent. So in that case, we can actually find out what the n is, because n is the only unknown right here. Now, I'm not sure if you can see what kind of possible mistakes that people can make. I can already see one. Can you guess what possible mistakes that people can make here? Like something's very tempting that people may do. Yeah, so you see the parentheses 3 and parentheses 4. It looks so delicious. It looks so tempting that people may actually multiply them together. And some of you did multiply them together in the beginning of the school year. Don't. Why not, though? Why can't 3 and 4 multiply together? Yeah, there's an exponent outside of 4, right? So they can't really multiply together. So what we do, let's just go ahead and divide up 3 to the other side so that we can cancel the 3 on the right. So on the right, we have just 4 to the n minus 1 power. On the left, we say, hey, what's 12,288 divided by 3? You may use a calculator. You may use well, just do it by hand. So 12 divided by 3, it's 4. And then 2 divided by 3, it's nothing. And then 28, you do 9, so you get 27. And then 18, you get 6. So 4,096 is the division. Okay. Now, it's a nice number. It's a nice number. So now I'm going to give you a minute. No, actually 10 seconds. Go ahead, use a calculator and guess. 4 to the what power? It's actually 4096. 4 to the what power? It's 4096. Go ahead, take a quick guess and validate it, verify it with the calculator. 4 to the what power? It's 4096. 4 to the power of 6. Okay. Now, you can try it with a calculator because you have a calculator, and it's going to be a nice number. It has to be a nice number. The n is going to be an integer. So if that's the case, what is n? N must be 7. Now, over here, can you also see what possible mistake that people can make when they try to write down the value for n? Instead of 7, they will write down 5. Why 5? Yeah, you see the 6 right there. You see the -1 right there. And your brain is like, oh, you see the 6, you see the -1. Guess what you do? 6 minus 1. And this is where your conceptual understanding comes in and say, well, what -1 gives you 6? It is 7. So we know that, hey, this is 7. So we know that the upper boundary for the summation notation will be 7. So this is how we will write it. And what's the nth term expression for the geometric sequence? Well, based on what we had before, I'm going to write this down over here in case you forgot. Okay, an for geometric sequence, it's a1, 1 minus r to the nth power over 1 minus r. Okay, so we have that, and therefore you have a1 is 3, 1 minus 4 to the 7th power, and 1 minus 4. Okay, strongly suggest you to use parentheses to substitute your r value, because it is quite possible that some r values could be a fraction or a negative number. So having a little habit of using parentheses would be good. I think I forgot to write another parentheses over here. Okay.
I still don't know what the n equals.
Okay, so for the n equals to 1 underneath the segment notation, is that we're telling people that please, when you add the numbers together, you start from where? N equals to 1. And where do you stop? N equals to 7. Okay.
And when 0, you start like 0.
Yes. Okay. So yeah, yesterday we talked about how the number underneath the sigma could be 1, and it could also be 0. And if that's the case, we will see those situations today later on. So if that's the case, make sure you count cautiously.